So guys, we were on the second step, extraction of highly reactive metals. First we are going to cover this, high reactivity or high reactivity metals. So for example, we'll take up Na. So basically all the high reactivity metals are extracted by electrolysis of molten chloride or oxide. So this is the main sentence, right? All the metals of high reactivity are extracted by the electrolysis of molten chloride or oxide. If it comes in your exam, how is Na, sodium metal, extracted? You are going to write down Na is extracted by electrolysis of its molten chloride. So basically Na uses chloride. K, Na, Ca, Mg, Al, these are high reactivity metal. High reactivity metal, only this uses oxide for extraction, rest of are extracted from their chlorides. So for NaCl, I'll write down the reactions that you have to write down. The first sentence has to be, when it comes in the exam, the first sentence has to be that Na is extracted by the electrolysis of the molten chloride, right? So Na is extracted by electrolysis of its molten chloride. Molten means that it is in molten liquid form, not liquid, basically melted form, right? Melted form. This is necessary for electricity because in this form it contains ions. So this is minus, this is plus, so minus is here minus, plus here is plus. Cathode is the negative here, one here, and anode is here. You need not do this diagram. We will do a few reactions that you need to know. This is just to explain to you. This is NaCl that we have. This is molten NaCl basically. So NaCl is ionic compound. It has ions Na plus and Cl minus. Na plus, this plus, right? This is a cation, gets attracted to the negative cathode. So Na is going to go to the cathode and Cl is going to go to the anode. So basically what's going to happen is Na is plus sign, right? Plus sign means it has excess of proton, so it needs electron. So Na is going to take electron. It's going to take electron from the cathode and form Na metal here that we require, right? We require Na, we are extracting Na, right? And Cl minus has extra electron. That's why the minus sign. Minus sign, it has extra electron. So it is going to give electron to the anode and form Cl2 gas at the anode, right? So guys, this is for your understanding that you should know. Na has lack of electron. It's going to take electron from the cathode. Na has lacks electron. It's going to take electron from the cathode and form Na metal at the cathode. So here Na is in the form of ions, right? Na is in the form of ions, right? Na is going to take electron, right? And it's going to form Na metal at the cathode. This reaction happens at the cathode. So the main thing, we are doing all this process to extract Na metal. So we are getting the Na metal at the cathode. This is what you need to remember. Na is an ion. It has lack of electron. It has extra proton but lacks the negative sign electron. It's going to take up electron from the cathode. This electron is actually going to come from the cathode and it's going to form the Na metal. Okay guys? And what happens at the anode? So at anode, what happens? At anode, the Cl minus gets attracted to the anode, right, because of the opposite signs, and the Cl minus that has extra electron is going to give electron and form Cl2 gas. So I have Cl2, right, Cl2 gas, so I have to write 2 here in order to balance it, and this it's going to give to the anode. So these two are the main reaction that we need to know, right guys? This is what you need to write down in the exam also. This is a reaction you can write down in your own words there. So you have to write down NaCl or Na. Na is extracted by electrolysis of its molten chloride. So you can write down this equation also, NaCl, and on arrow you can write down electrolysis, and here you can write down molten form, and you can write down Na plus Cl2. It's 2 here, so I have to write 2 here and I have to write 2 here, right guys? So this is the first reaction that you write down. Second reaction, what happens at the anode and what happens at the cathode. So I'm telling you again, right? I'll tell you this process again if you want. So there we are. Or I'll take another example and then I'll explain this process again to you. So let's see how aluminium is extracted. So aluminium is extracted by electrolysis of its molten oxide. OXIDE. So I have this, I have this, I have my cathode here. Cathode is negative, and negative terminal is always connected to the negative. This is negative, this is positive, this is positive. The small is negative. This is cathode, this is anode. I'm just drawing it quickly so that you guys understand. And you have Al2O3 molten form. Again you have Al in the form of 3 plus gets attracted to the cathode, and you have O2 minus gets attracted to the anode. The reaction remains the same. What happens at cathode? At cathode, aluminium, so Al3 plus, right? Al3 plus, it lacks electron. It lacks 3 electron. Basically it is 3 plus, so it has to actually gain 3 electrons, and it is going to form aluminium metal. And at anode CO2, so O2 minus, extra electron gives 2 electrons and forms O2 gas. I have 2 here. I'll write 2 O's on this side also. I've written 4 electrons here, right? And this is, you need to write down that it's actually taking from the cathode, and here it's giving to the anode. And one main reaction that you have to write down at the beginning or at the end is Al2O3 on electrolysis gives you Al plus O2, and this is molten form, and I'm leaving the balancing part. So this is